Okay, well, thanks everybody for jumping in to today's presentation. We're going to do an EdgeWise Masterclass. All right, I think we are good to go, so we will jump in. First of all, I will kind of introduce myself. So I am Justin Domer. I'm a product EdgeWise product expert. I've been with ClearEdge for 10 years and working with EdgeWise the whole time. So I've spent some time in EdgeWise, and I think I could say I know it pretty well. Through that process, I have done a lot of virtual trainings. We sell EdgeWise internationally, all across the world, and we are basically able to do that, and then as well as doing some in-person trainings. Looks like we're jumping. Yeah, so we'll kick off a poll here, just out of curiosity. Have people who are in this, have you actually done a training with EdgeWise? We're kind of curious on your current amount of training, if you've been trained before, if you just kind of the status. We're very curious to hear where people are at so far. And yeah, so we have a lot of people who figured it out. I think that's an interesting point. We'll kind of talk about some of the recommended workflows as well as the options for it. And then we can kind of work through from there. Okay, but very cool. All right. Yeah, so let's see, we'll keep going. So a couple of things with the presentation. So this is a standard webinar, so all the participants are muted. There is a chat, so please toss your questions into the chat in the tool. I will keep an eye on that, and then we have Trevor McGough also with us to keep an eye on the questions and try and answer. This is going to be pretty fluid, so this is something that, if we see a lot of questions, about specific topics, we want to cover, what people have questions on. So if you have something you specifically want to know more about or that you've had trouble with, toss it in the chat. Even if we don't cover it directly during this, we'll be following up with anybody who puts questions in to, try and answer it as best we can. The last part is we will send a recording out. So if you want to review this is definitely potentially a good one to have to see these tips and tricks and kind of walk through it yourself. Okay, so for today's agenda, what we're looking at doing is we'll start with kind of the importing process, like what we recommend for bringing into EdgeWise, computer specs, things like that, data that works. We will cover briefly some of the spec management stuff. There's not a ton with EdgeWise, but we'll kind of cover some of the options. And then we'll dig into some of the different workflows. The kind of core workflows will obviously spend some time in piping, but we want to cover structure and some of the tools there and tips and tricks. And then briefly on modeling, ducting, and cable trays and some walls. And then the last part is just covering exports. So there's some interesting export options. So point cloud exports can be really powerful, and they're something that people may not know about. And then just general optimization for getting your model to work as well as possible in your final deliverable. So Revit or Plant 3D, E3D, all these different tools that we can actually integrate with. And the last parts will be some discussion about how you can do team modeling. So if you have more than one person who's working inside of EdgeWise, then how to break that up, and then we'll finish with a Q&A session. So just any other questions. But again, if you have questions, feel free to toss that into the chat for the questions. So one of the things we want to do here is as part of that, we just kind of covered what we were thinking would be useful, but we're obviously super curious to hear what people are really interested in. And so if we see a huge interest in one specific topic, we can kind of dig into that more. If there's more stuff that we want to look at, we can go from there. So that will be obviously a big component of the process. Okay, and so obviously, unsurprisingly, most people are interested in the piping and structure. That's our, I guess, bread and butter, and a great one to go into. And there's a lot of tips and tricks there. We'll still stick around for the ducting and side of things. Keep it pretty brief, spec management, and we'll go from there. So, cool. I appreciate everyone, filling in answers there, and that helps us kind of understand what we should really be focusing on here. Sweet. All right. So the first thing we'll talk about is the data that you bring into EdgeWise. So, the biggest thing here is just it's a classic garbage in, garbage out. And that is true for most workflows, but it's especially true with EdgeWise because of the automated approach that we take. is very reliant on the data that you import. For those of you who have known EdgeWise for a long time, we've had the ability to automatically extract piping from point clouds for more than 10 years. The original algorithm that we had was structured, and just for kind of brief information on that, terrestrial scan data where you have the tripod scanner and you take individual scans and you put that all together. And a structured point cloud is one that remembers that. So it knows where points came from, what scan position and scan station they're related to. And then, the other option is a unstructured point cloud, and that's where there's a lot more flexibility. And so we started supporting unstructured point clouds 3 or 4 years ago with EdgeWise piping, and we've had that for walls for a long time as well. So that's a major shift in our workflow, is to the ability to work with that. But there are caveats, and there's definitely best practices. So in general, EdgeWise is going to work very well with kind of any standard terrestrial scanner from the major manufacturers, things like Trimble, like Faro, Tropcon scanners, and ZNF is great. Who else? Regal is good. So, all the kind of standard manufacturers for, your kind of traditional workhorse scanners, those generally will work great out of the box with EdgeWise, either with the structured workflow where we keep the structured point cloud and we know all the different scan positions, or unifying that. And there are a lot of advantages with unifying a point cloud. It's much smaller. And so we kind of balance back and forth. I think there's basically, it's just kind of the results that you want to find if you're working with structured data or unstructured data, and it's something that's worth, experimenting with a little bit on what you're happy to see. One advantage of the unstructured algorithm is it is multi-threaded. So if you have a beefy workstation computer, then that is good. That will run faster, and that can really impact performance for processing time. The other major part of the topic is going to be, a common question and a conversation piece now is mobile versus terrestrial. That's, kind of a newer question, which is super exciting. I mean, we have seen the evolution of mobile scanning, really move in a great direction over the last 10 years. It really wasn't viable until recently. And so now that it's there are some manufacturers who are doing a really good job, and that's something that works well in EdgeWise. But not all mobile workflows are the same. And so, EdgeWise process scans algorithm are very susceptible to noise. So if there's a lot of noise in the point cloud, that does impact our ability to automatically extract piping. And so that should be kept in consideration. Things like drone workflows are generally not there yet from what we've seen. If somebody has a point cloud from a drone that is very crisp data, we would love to see it. We're always trying to keep up with where technology is today as far as, who we can recommend. We've seen great results with Navis. This is going to be, some of the workflows we're going to do are going to be on a Navis data set, kind of showing that mobile is an option. And we have seen some really promising data from other manufacturers like XGrid and Jexcel. So it's becoming a much more viable option. So enough about that. So we'll keep going into the coordinate system. So this one's a big one, and anyone who's actually done scan to BIM projects will know that getting coordinate systems wrong is very painful. That's a bad time. And so just like any other workflow, really thinking about what coordinate system you want to be working in and need to be working in is very important to do before you start working anywhere, in any process. That's a really important thing. That's true regardless of your workflow. If you're going, you always got to make sure you're in the right coordinate system. And that's still true for EdgeWise. The high level for EdgeWise is that we do not, you do not want to, EdgeWise does not change the coordinate system at all. So wherever your point cloud is, we import it and we work in that location and we export in that location. So in general, it's pretty straightforward with EdgeWise specifically. You will figure out your coordinate systems that you're agreeing with for your project, for your client. And that would be, what you're bringing into Revit or AutoCAD, like where does that need to be? That needs to be pre-decided. And then effectively, as long as that coordinate system is saved to the point cloud, which is very important and recommended anyways, So you don't have to deal with transforms when moving projects around. You can just drop the point cloud in. That works great with EdgeWise. So it's highly recommended that you spend some effort and time getting coordinate systems figured out. And that's true regardless of your workflow, outside of EdgeWise or otherwise. And then taking that point cloud that's had that coordinate system agreed to and defined, and bringing that into EdgeWise. EdgeWise does work great with large coordinate systems. We have no issue with that, unlike some other workflows. So there's pros and cons to that information, but it's kind of you can use whatever coordinate system you need to, and that should work. But it's just something you make sure you check that one out before you jump in. The only other part on this slide, just to leave it, is recommended hardware. Again, process scans is multi-threaded for unstructured workflows, so unified point clouds. And generally, we just recommend a fast CPU with lots of cores. That will be a i9 workstation CPU, Ryzen Threadripper, or just Ryzen CPU, Ryzen 7, Ryzen 9. They have fast, high core cloud, and that's going to make it run faster. And obviously, NVMe SSDs and reasonable amount of RAM. Effectively, it's like if you're able to run various software with point clouds, then it should work well. But that's really the baseline of the recommendation. It's just we use the CPU a lot. Okay. So moving along, we will jump into the next thing, just talking about process scans itself. So this is the dialog box when you import scans. For file formats, we work with lots of different formats, most of the standard ones. And, if you're doing a unified point cloud, so E57, Recap, RCS, RCP are probably the most common. And then we do support native scan files, depending on the manufacturer. Something interesting with this is if you want to try different process scans, you're going to try different settings when you extract pipes. Instead of reprocessing the original point cloud data every single time, generating a new EdgeWise point cloud, you can use this third option here, which will basically reuse the C3DB, like the point cloud that we make and we work with, which is similar in concept to like a recap point cloud that you load into Revit. It's kind of the native format. So EdgeWise C3DB file is the EdgeWise point cloud. That way, all you're doing is processing pipes, and you're not remaking the point cloud. So you can kind of skip the importing point cloud data and just try different settings with process scans for walls and piping. That can be nice if you want to try some of the different settings. Now, speaking of those different settings, we have the options here for piping. A couple things you'll see here. So one, and I know this is a big request, and I believe it should be in the next release, is we do have this remove pipe outside of the diameters range specifically. This is currently in the most recent version only in the unstructured algorithm. This will delete anything that's above or below these values in pipe diameters, kind of a really simple cleanup option. That is being added into the other option, our original structured algorithm process scans. So that's an important one. That one's a very helpful one. We'll cover a little bit of the workflow there, but that's nice. And then the big one is just these settings here, when to use them and what they are. So the default is minimize false positives. This is just purely, what it's saying, it's basically we're pickier with the automatic pipe extraction that we do. So this is probably the recommended setting for terrestrial scans. Really, should just work across the board if it's terrestrial. And then in general, for mobile workflows or mixed, kind of hybrid approach where you have terrestrial and mobile, maximize number of extractions can be a better option. It will just it'll be nicer about stuff that it keeps. You will have a few more false positives, but you may end up with more overall piping. And that's kind of the balance that we're always trying to strike, is getting as much automatically created as possible and minimizing, incorrectly extracted stuff. So that's a big one for this. And again, that, using the original database and kind of rerunning, if you want to try, like can be reasonable depending on, if you want to experiment a little bit, it's just running both of these settings and making two different models and kind of seeing what you prefer as far as the options and the output. Okay, and so that is, kind of the processing side of things. And so at this point, we'll do briefly in the spec management because we want to kind of talk about that a little bit. So spec management in EdgeWise is pretty basic. We are not trying to, we never wanted to be a big spec management tool software. We're kind of, we want to do enough that gets it into your final deliverable like Revit or Plan 3D or E3D within reason, but not, trying to actually manage huge catalogs inside of EdgeWise. So we've tried to strike a balance with that. And so the actual specs themselves are pretty basic. So key things are related to, so piping and structure have the kind of main two catalogs that you're working in. Ducting and cable trays are more just sizes. They're just different size rectangles, basically. So for piping, the key thing with piping is that the only value that is really being looked at by your final deliverable, and that's something to really keep in mind, is that at the end of the day, the value of this is what goes into Revit or what goes into Plant 3D or AutoCAD or Inventor or E3D. And so, we want to kind of keep that in mind of like what we can model in EdgeWise versus what gets into those deliverables is really the important question. And the value that actually gets sent to like Revit and is used by Revit is going to be the nominal diameter, and we'll see this in the piping standard when we go into that workflow. But it's really just the nominal value, and so that's the only thing that you really need to do if you want to kind of define initial custom specs is your actual diameter and your nominal diameters. And that's the value that gets sent out and really evaluated by the final deliverable software. And that's the one to keep in mind. There's other information for valves and flanges that we'll kind of briefly poke on, but that's the high level, and it is a spreadsheet that you can manipulate. There are restrictions. Plant 3D is, if you're going to Plant 3D, you can only use the built-in specs for EdgeWise currently. E3D, we're working on improving that workflow continuously, but that's actually a lot more flexible in some ways. And then Revit is we're kind of making generic pipes with family objects, and it's really just looking at the nominal value, and then after that, it's a standard family that you can switch out for the system type or the system. So that's the important one for piping. For structure, we do have a really nice workflow for E3D, which is that you can export your steel standards directly from E3D, and then in EdgeWise, there's a tool now that can read those CSV files that you created with E3D and actually natively generate an EdgeWise steel standard that you model with, and then that contains all the metadata needed so that when you export to E3D, it passes right back through. So it's a nice circular approach. We're looking at applying that in other ways as well, but it's all spreadsheets, and a lot of it is built in to the existing workflow and the standard install with EdgeWise. Okay, all right. So we'll kind of jump in now. So we've this is the first half. So now we'll kind of look at some workflows. So I'm gonna turn off the presentation and we will look at EdgeWise. So hopefully we can see EdgeWise here. So this is a Navis point cloud, and all I've done at this point is effectively I ran process scans and did in this case I said keep the maximum number of extractions in that, and then options and everything else is default. So this is kind of our raw input, and what we'll do is we'll just do some modeling and I'll kind of cover how I approach cleaning up a model and then go through some specific examples of like where it's tricky to model, how we can get around that for piping specifically. So a couple of things we can do just to cover some of the conversation there before we go into the modeling itself. One thing to point out, and this is even if you've used EdgeWise for a long time, we do have a recovery function. We're doing auto saves with EdgeWise, and it happens. It's based on actions, so it's not a time thing, but it's like if you modify or do certain actions in the software, it will kind of trigger an auto save. They are saving in your documents folder. You should check that every once in a while and clear it out. So it's a good thing to check. I open EdgeWise very often, so that file can get kind of big. That folder can get kind of big if I'm saving all the files in the back end. But it is something, if something goes wrong, if it closes unexpectedly, like you can go check it and basically, hopefully save you some rework if it did catch it, but that's something to keep an eye out for. Some other points, so the pipe standard editor, this is that spreadsheet. So we can kind of take a look at it again. If I expand this and I look at it, it is a spreadsheet that I can export and I can import in here. And again, the only value that's really getting looked at when it comes to the actual end deliverable for piping is going to be this nominal value for, depending if it's metric or imperial, and we're looking at the actual diameter. And so these three columns are really the main meat of the information. Everything after this is looking at creating the dimensions for flanges. So that's what these values do. And so this will actually kind of draw different shaped flanges with different metadata. And that gets sent out to different workflows. And then additionally, it's just very basic coverage for types of valves. And all we're doing is tracking the length of the valve. That's it. And so there's a bunch of mapping options, but the core of it is, and again, depending on the workflow, it's really easy and fast to just create all the pipes inside of EdgeWise. It can be useful to do the valves, but if you're in Revit, you can just place valves very quickly, and there's some other advantages to that workflow as well. So it's some options, but that's just what we were referring to. And the last thing is this is the import function for Aviva. And again, you go to Paragon, you can export your steel catalogs, and we basically generate an EdgeWise steel spec for that. Okay, so we're going to start with structure for piping. The first thing I'm going to do now is I'm going to select this guy. We can take a look at this. So I'm going to turn off the point cloud, and a good hotkey, if you are not familiar with it, and I'll cover some of the hotkeys here, is the Z key on the keyboard, the Z key. That's going to hide the point cloud and turn it back on. So it's nice to have that very readily available. It's very fast. It can do that pretty much instantly, even with huge point clouds. And being able to turn it on and off is very nice. The other critical hotkey, if you haven't seen this one, if you're ever really not having a good time trying to navigate, it's probably because you're not using the focus option in EdgeWise navigation. So we're always orbiting around the center of the screen, and where that center of the screen is dictates that orbit. And so what you're doing is you're kind of moving that around. The one option is just you can right click on point cloud data or geometry, and there's this focus option, and you can see F. And we can click on that. That'll zoom us in, and then it kind of zooms in and we'll actually focus in on that object. The other one is the F key on the keyboard. So if you're not using that F key every 30 seconds, you're probably navigating inefficiently. And that can be really frustrating if you don't know that's there. So that's a big one to hit. And that may be hopefully that's not too painful news for people who if they've been struggling on that one. So those two are really common. I'm going to hit those buttons the whole time, basically. I mean, you're constantly turning the point cloud on and off. You're readjusting that focal point, and just moving around. So for this process, though, we have our point cloud turned off, and we can see a lot of junk that we don't want. And this is kind of the byproduct of automatic pipe extraction as it is right now, where we found pipes, but those pipes happen to be railing and a lot of scaffolding in this case. So the first thing we'll talk about is how to, some quick ways to clean this up. And really it's going to be based on diameter. So for those of you who have done process scans and, have done it before the filter where, we make lots of little pipes and lots of big pipes, and now the filtering gets rid of it automatically. Sorting by diameter can be really powerful of just doing that in the smart sheet. And so the smart sheet here is the first one we're going to look at, the parting flow smart sheet. And the first thing I'll do is, I'm going to go through and I can get rid of things like with more of a drag and grab type thing and delete groups of things. Or in this case, especially for the scaffolding, I'm going to use diameter, right? So if I click on an element here, I see a lot of stuff that's all 55 millimeters or very close to 55 millimeters within, a couple millimeters. So it's probably a safe bet to say, okay, if I grab this and I'm going to grab, the other direction a little bit. So it's, 50, 55, and I do a shift select. You'll notice that most of the stuff I've selected is actually is a lot of the scaffolding. It's not a perfect method, and you can kind of work through it, and you might get unlucky and there's a bunch of pipes that are the exact same diameter as the scaffolding. That would be a bummer. But this is a really quick way of just getting rid of stuff that we know we don't want. And I can get, more aggressive with it as far as like seeing different options. And again, but we see that we cleared out a decent amount of stuff. There's still these diagonal ones. So these are 54. So I think I'm just going to grab anything that's like 53 and go a little bit more aggressive to see if we can clean stuff out. So we'll just kind of arbitrarily grab that one and we'll go to 57 or 57, 58, something like that. That looks pretty good. We can get rid of those. And that's, one way to approach it. Same thing for railing. In this case, that's another one is we can just get rid of it. Now, we can get really fancy where if you want to keep some of the geometry, there's ways to split the model up. And that one's a little bit trickier. That's really the advanced stuff is like looking at, and I'll kind of talk about it, but it's just something and again, this is kind of going over like what you could do and what are things that are impossible in EdgeWise. There is a split based on lever or split tool, right? So merge split tool. And what this does is it separates pipe models based on their layer name in the chain info smart sheet, which is a different spreadsheet. And this is definitely more advanced because, at this point, normally if we were looking at this, we aren't even using this. This is actually a tool for like looking at spools, like the connected different piping runs. But we can kind of use it to do some interesting things where like I can grab, in theory, I could grab all of these things, which are individual lines right now because they're separated, but something that these are 36. So if we sort by diameter, same idea, potentially I can go through and I'm just going to grab everything that's, we'll kind of grab stuff and see what we get. If I had something where I was like, oh, all of these are the same size, I actually want to keep these, but I want to separate them. You could do something like this where you go in and set them with the chain info smart sheet. You can do multi-edit and set a layer name. And then once you've set that layer name, you can then run that merge split tool and it will create a new pipe model that's these elements in one model with that layer name, and then another pipe model that's, layer 0 because we haven't applied it in another file. And so it's an interesting way of separating things. It's something that you can do it right up at the front now, but that's less common. But it's a really powerful tool for other approaches, like if I want to break up my ducting systems and my conduit, or if I want to get more fancy with my, any system. If I want to like say these pipes are in one group and these pipes are in another group, I can physically separate those models in a way to, organize things in a different way. So that's definitely a more advanced option. But that's a big one, is just getting rid of more stuff. So we would go through that way. The other option and things when there's like straight lines is the multi-select tool. And this one is very straightforward. It's just drag and drop, and then I hit delete and get rid of them. And so if I have like a good way to do that is, in this case, like for this specific model, I just don't even, there's nothing in here that I am interested in for the scaffolding on this tank here. So I'm just going to get rid of these and really just focus on, the main segment that I have. So those are really very straightforward, ways to just kind of clean up things to start with. And that is something you want to start with. The other QA tool that exists is our QA mode. And so if I click on this, what this will do is it'll actually take me to a nice view here of this element. And I'm going to turn the point cloud back on. And we just see how things fit. Now, this one's a little tricky because like stuff that is round is going to look really good here. Context is helpful. So in this case, this is round. That's not what we want. So we're going to delete it. This applies across the board for diameters too, right? If you have stuff that you only need to model piping that is a certain size and up or down, just delete everything outside of that scope. And that's your first step, basically. And so that one looks good and we can approve it. So there is an approve function and you can keep track of what you've done and kind of work your way through the model that way. But that is, again, a different option for the different models. With the tooling here, coverage percentage is a good one. Stuff that has really low percentage coverage is probably not a pipe. And that's what we usually sort by to go through that way. So that one's probably not a pipe. Anything with straight lines we don't like, we're going to get rid of. And so that's another part of the QA process. Okay, so that is the kind of tips and tricks for QA is just how to clean up, after your automatic pipe extraction. And it's a combination of, kind of leveraging bunch of the different tools to get rid of the stuff that's not, that we don't want. From here, we're going to go into some of the other parts of the workflow that are important. So in this case, I'm just going to continue. I'm going to get rid of these guys too, just to kind of open this up. So a big one is going to be the easy connect function. This one's a really powerful option. This is just how aggressive the bar is. If you go to the right, it's going to be more aggressive with making connections that are maybe farther away. This is good if you have really simple pipelines that are straight lines or, very kind of consistent. If you've got a lot of interconnected loops, T's and things like that, then we would probably keep it at the default or even turn it down. You can run this multiple times. And so that's a nice feature is we can run this. We're going to do an initial run and starting point. And then, if we want to, we can then, if we make more stuff, we can model more. So, so we've got kind of these main systems. Because of this workflow, we are trying to do some specific use cases for like, how do I want to say that? So it's going to, like, we can create stuff and then we can rerun Easy Connect. We can do, that sort of approach that way. And then additionally, these segments here kind of represent the connections. Those are temporary, but they can be used for kind of showing where those connections were, and then and through the workflow, we're going to get rid of them. So a couple of things for the tips and tricks on actually modeling. So a really good example of something tricky comes into things where we don't have room to extract stuff. So this is a great example that comes up pretty often of something that can be difficult. And this one may not be too bad, but something that's a really core part of the EdgeWise workflow is that we're taking pipes and we're connecting pipes. So we need a pipe segment to connect to another pipe segment to create an elbow. And then valves go on pipes. We kind of need a valve object, a pipe object everywhere between all the different components, and so that can be tricky when there is no pipe between two things in the real world. And so in this case, this is actually looking at it as two elbows welded directly together. Super common. That is a very normal thing in the field. The way that we hope to model this is we want to draw a box and draw like a little sliver extraction, and we'll kind of get that one set. We have our connect tool, and again, I'm going to use hotkeys a lot, but there's a connect tool, it's the C key on the keyboard, and that will create our elbow there, which looks reasonable. We can create our elbow here, and that's going to fill on that side, and that looks pretty good, right? That's not bad. There is the option to modify the elbow bend radius, and that could be pretty cool, or that can be useful for a couple things. This one you got to be careful with because, again, it's always important to keep in mind is it's not just what you can do in EdgeWise, it's what can you export out of EdgeWise into your final deliverable. So for Revit, we can do very flexible elbows. We make our own elbow when we import a Revit family elbow, and that has this elbow bend radius, something that can be a modified parameter. But if you are, assuming you're planning on switching out to a different value, that may not work for your workflow. And so, or if you're going to like Plant 3D, that doesn't really apply the same way. Step, you can do whatever you want. That's just geometry you can push out. So there's just restrictions for, sure, you can edit the elbow bend radius, but it's important to keep in mind of what are you able to actually export into your final deliverable. So you don't want to go spend, a ton of time editing all the elbows to be perfect if it turns out that that information can't actually be sent to your deliverable, right? They just wasted time at that point. And so that's something to keep in mind. If you are able to represent it, if it makes sense for your workflow, then it can be nice. You just hit the edit tool and you can click on the element and adjust the elbow this way. But that's a common action. So but the question is, what if I can't get that little pipe segment? Right, that's the thing that we were able to do in this specific example, but there's probably another one in here somewhere where that's tough, just because the bend radius is very tight. So like this is a good example right here. So it goes, basically an elbow, a pipe to a reducer to an elbow to straight into a valve, right? And so in order to model this, I'm going to first extract a pipe segment there. I'm going to try and extract a pipe segment here. And again, I'm doing like little slivers. I'm going to try and extract a little segment down here. and we'll see if we can. And if we can't, then we can, even if we can, it actually looks good. That would be kind of the approach. And so, I'm going to just kind of put it together and we can see the results. And you see this is a little bit off here. That should generally be get fixed in the next stage. So we're going to just kind of ignore it right now and connect things up. But if I were to do the regular connect tool with the C key, I can connect these two together. I can do the edit function, so I could try and adjust the elbow bend radius a little bit. Right, so I can drop that down to maybe 1. And that looks good. I want to do my reducer here. Now, if I just do the R key on the keyboard and I do the reducer, then it's going to set the length based on the position. So if I want to get that reducer correctly defined, I actually Control Z. I'm going to use the edit tool to grab the end of the pipe here. And this one's a little, the orbs don't resize like automatically right now. You got to zoom in and out and click on it. So it's a little quirky there, but you want to, basically get the length you want to go. So that's where the reducer starts. I have this one that looks good enough. And I'm now going to add the reducer and it'll actually add that in. So, that's the kind of general approach. Now the flange, this one's another one that's like, trickier with it's kind of setting reducers. So there's lots of little spots that can get tricky for setting these up and kind of going into the detail for defining this, because the other portion is like, we don't want to just have this pipe hanging. We kind of want it to be longer so that we can then, add that flange in to add that component. Now, let's see. So that's how we would do it. And again, this worked out actually not that bad because we were able to extract that little segment. So that we'll try and find another section here that we can't do that, or we'll just not be able to do it, for the example. And then we'll kind of move into the next section here for piping. Yeah, and if there's any questions on anything you see, then toss it in the chat too. We can keep an eye on those as well. Let's see, I think we can go right here. This is kind of the same example. So we'll assume we can't actually extract this segment. There's not enough point cloud data here. So this is actually, the nice thing about mobile is there's lots of coverage generally. This has actually got a lot of the point cloud coverage, so this helps. But if it is not, there's not enough point cloud data, we may not be able to extract this. We'll just do an example of that. So we're going to go and we'll do the rest of the segments like normal. So we're going to do extraction here. We'll try and do a little extraction here. But to create this elbow, there are a couple different ways to do it that can be pretty sneaky. I'm going to go through and jump into like a copy paste type thing. There's a tons of ways to do this. So there is like an append function where you can go through and you can actually, instead of doing a connection, we can just make an elbow, and I can like put it here. We're going to do a 1 bend radius and leave it at 90 degrees. It's going to just make an elbow. This one, I generally don't love this one just because it's super finicky with the left to right, like the lateral position. That looks okay, but like when we go to rotate, so we have a rotate function, we can flip this guy around, and it's not quite, we see that it's not quite right. So the pain point is there's no good way to slide that. Like I kind of need to undo and then, edit and adjust that way a little bit, and then add the append function for the elbow. So it's pretty clunky to do it that way. Hopefully you don't hit this too often for like actually running into this one to get it, to have to deal with it. So I generally, like I said, I don't really recommend that, and it's also finicky based on this alignment. So the other option is something like you can select this, and I can just do like edit, and I can select it, and I can do Control V, Control C, or copy paste, and you can just kind of grab the geometry and you can move it around. Then I have like a select function. I can select it. I can do snapping to Z axis, and I got the thing, and I'm just going to pull it down and just kind of wiggle around. So this is where the focus option is really helpful. I don't know if you've seen that, but like when I have the focus on, it's super easy for me to just kind of move around into the different positions as long as I set that focus on the object I'm looking at. But so that looks good, or close enough, and then we can kind of tweak it that way. And now when I do the normal connection, I'm going to go back to the regular insert mode, and then I can just kind of connect these two up. So that's generally what I would do is something like that if I can't extract this segment. And the hope is you can, but that's just the tips and the trick for that one. Okay, so that's like, especially for modeling, that's a big one that comes up a lot, and that can be really helpful to kind of get around those. is using some of these extra tools, the rotate, the move tools to just kind of modify the segments to get those as accurate as possible. So that is, some of the main pieces there. To finish up piping, so we can go to structure and we can look at the other sections. We have the clean function. This one's a really critical function. It is kind of a beast in the workflow because it's doing a lot of things. And one of the first recommendations we have is not to run clean globally. It's generally recommended to do it more piecemeal. You can do it globally, but it's doing a bunch of important stuff. And so it is nice to be able to, run it on a specific set and just say, I want to clean this one specific model, this pipe run, and set it that way. The default workflow keeps as built conditions. So we will keep bends and bows if you leave it at the 10 millimeter default value, or the inch equivalent. That effectively is trying to straighten things out when it can. And it just says, like, if it can't be straightened out, like if it's too far off of the point cloud, if we make it a straight line, then don't do it. It's kind of the way to think about it. If you want a design intent model, you want to just export just straight out to a straight line, basically, then just raise this value up way higher. So if I make this, a meter or even 100 millimeters, this will basically make it a straight line. The elbows will still be non-90-degree elbows. We're not straightening out, like we're not completely moving everything around, but it will just make connections straight lines. So that's a useful thing if you need to do more of a design intent model. That's a big one. But we'll run with just the default setting, and we can kind of see what happens here is when we actually close this, we can look at the different segments. So that was a bunch of pieces. And in this case, it is actually a straight line, and that's because it's close enough to a straight line. We just made it a straight line. And so that's what clean is doing. One of the things clean is doing, and it's a pretty important stage in the workflow. And so we do recommend kind of doing that more piecemeal. We can do clean. I'm just going to do it globally. If there's loops, which there almost always are, that does weird stuff. So we generally skip those, but it'll leave it highlighted at the end of the process. That's another good one, very quickly to show, and then we can jump into structure. So there's a loop in here somewhere. There it is. And so in this case, if we do the loop, that just happened automatically. This is, in this specific case, this is still the railing. So I'm just, or the, not railing, scaffolding. So I would just delete this whole thing, right? We're just going to get rid of all these segments. But if I didn't want to do that and I wanted to get it, I could do something like this where I say, okay, I'm going to delete an elbow. I'm going to run clean. There are no loops now, so it's going to be happier. And then I can then add the elbow back in. And if you do elbows, it doesn't do as much. If you just remove the elbow and put it back, it gets around a lot of the pain. Okay, so that is some of the core stuff for piping. Applying standards just to understand what that is doing. It's just changing the actual diameter based on the spec. So in this case, we have actual diameters. These are averages based on the point cloud. If we apply a standard, it's going to bump this value to the closest actual diameter in that standard and give it a nominal value. So if we do ASME, that's going to bump it to the actual diameter in the ASME standard for a 6-inch nominal pipe. And then that 6-inch nominal is what we get when we go to Revit. So that's the thing that we want to keep in mind. For the sake of time, we're going to jump into the structure side of things, just because there's a lot of other pieces we want to go through. But for structure and for cable trays and for ducting, the way that we want to make a structure model is we're going to go to the blank model section and we're going to create a new structure model. And that's true for ducting and for cable trays. So if you want to create those geometry, you need to start by making a new empty file and then effectively working through that. And so that is the next one we're going to go through. So we're going to do structure here. And in this case, this will turn off our pipe model and we can actually hide this. And it's an empty project now because we've turned off everything there. So for structure, this is going to be based on the catalog that you have imported and working. This is a European, we'll see if it fits, but basically we need to define the standard we want to work in. And so I have a custom European standard that seems to fit reasonably well for this project. And I'm going to leverage that for actually extracting out everything inside of here. So I have my EU standard. I've got my different types of geometry. We're going to stick with an I-beam. And then this is a list of all the I-beams in that standard. So we're going to go hit extract and cover this. And so now we've created that I-beam. We want to hit the review. So this is, again, this is super dependent on the standard. And if you have the standard, and this is where the custom standards can't come in. In this case, though, we have some options. So we're going to try and use the resize button. And this will actually kind of go through and resize. And that looks a lot better. There is thicker and thinner, which will kind of jump between different sizes that are similar to just try and see if there's a better fit. But I think that looks good, and we're going to stick with that one. The recommendation for steel is just set to select. When you got a good size that you like, when you're going to make more of that same one. That's going to skip the phase where we go and look at the big list and just give us an H300A. And so now if I want to go through and I want to extract another element that is similar, we're going to do this one, and we're going to draw our box. We're just left clicking around the box, and that one looks pretty good. We're going to tweak it a little bit. And so that gives us our option there. And this does lead us into, if I want to switch around to other structure, I can do other elements. So I'm going to basically just say, okay, in this case, what I'm going to do is I'm going to go back to AutoFit. And if I hit A on the keyboard, it'll jump back to AutoFit, and I can extract another section of I-beam. So we can see if this one looks good. And what I'm doing is I'm actually kind of setting up to do the next thing, which is pattern extract. So that's a big one that we want to cover, is just what we can do with pattern extract when we have the right setting set up. I think I want to do a little smaller. Let's see if we can find one that fits better with the thinner. Nice. Okay, that looks good. All right, and so with this one, we got these guys set. We have our little arrows here. We can kind of grab these and make this a longer section, like so. And we'll pull this one down as well. Again, focus is your friend to get the right positions. We can do concrete columns as well. And I think that looks pretty good. We'll bump this guy up to the top. So we'll do this. Okay, so what's cool with this is we should be able to do now, we can do a basic pattern extract. And so pattern extraction takes advantage of the fact that in structure, there's a lot of repetition. And so in this case, we can kind of see there's bays that seem to be pretty consistently spaced in the structure, super common. And so instead of extracting every single one of these one at a time, pattern extract lets us go through and we can grab like 2 of these guys. Or in this case, this is where it gets interesting, is like we can grab like this one and this one, and we can say we want to repeat you guys. And what this will do is we're going to use the tool called pattern extract here, and this is actually the idea is saying, okay, we're going to select other pieces of geometry that are similar to in the spacing that we want. And so these 2 columns represent the spacing that we want to go look for more stuff with. And so we select, and then the green elements are what we want to make more of. Now I specifically didn't select this one also because we're going to take this and we're going to do kind of a smart array. And this one is going to go there, and that one's going to go there. So there's going to be repeating. And so instead, I'm going to select these 2 so that there's no repeating elements in the pattern. And if I select the pattern extract, I can select this first column, and that's our starting point. And then it's kind of, I think about an arrow going over to the left here. And I'm going to double click on this one, and it's going to say pass 1, 2, 3. And so it's extracting both of these elements, and it's going to try and extract all of them from the point cloud. And the key here is it's actually doing it from the point cloud. It's not just copy and pasting. It's fitting to the geometry in the point cloud. So that can be really cool for lots of things. And in this case, like if we did like 1/2 of if we basically went to the end here and we model like these, the diagonal supports here and the other piece, that's going to get picked up and added in. And we can do this over and over and over again. You can compound it a lot to basically define the spacing. So in this case, I want to do this piece of steel here. And didn't quite get it right, but we'll just do a quick tweak. So if you hold Control, you can do a rotate there. There's also a rotate to flat, which can be nice. Refit is also very nice, which will straighten it up for the point cloud. And so we'll get a bigger guy here. And that looks reasonable. We've got our extend functions. We're going to extend with the C key on the keyboard. And again, if we want to do this, we can do pattern extract with just one element. We can do it with a bunch. We can do these same elements here, and that'll try and do it across the board. Didn't quite work yet, so we can try a different segment, and so we'll just try 2 different ones, and then it filled it in, right? So, and you can go through, you can grab it and just repeat tons of times, right? So this is something that can be really fast. It's a lot more more interesting when you spend some time doing like kind of initial extractions, that seed. And then you can kind of repeat a ton. If you do like a whole bay, you can take that whole bay and you can repeat it. But that's kind of the core of the structure. And let's see, I think that's lots of stuff. Okay, so at this point, we've got kind of the main things for the structure side. The last things I want to talk about, so we didn't get too much into the ducting things, and I think this is just a lot of information. I will say a couple pieces. So ducting and cable trays are the same basic controls as structure. So if you want to make a duct model, you're going to do the same thing. You're going to go here, make a blank duct model. It's going to create a duct, element to click on. And then, if we click on this, we're going to see ducting up here. And the same thing for cable trays. These are going to actually give us the tools for it. And the same, it's going to be the exact same extraction function. The only difference is going to be the connection tools. And the big tip there is just use the align functions a lot more to get things squared up before you do the connections for the elbows and things like that, and transitions. The last part here is going to be exports, and let's talk about that a little bit. So some key things for exports. We have added a export based on selection option. So this is a big improvement for a lot of different workflows, and it works pretty much everywhere. And the basic idea is that if I have something selected, when I hit the export button, that's what's going to get exported. So in this case, if I only wanted to, for instance, export let's see, if I only want to export like these 2 sections, I can hold the shift key and select it. And if I hit export to Revit, it's only going to export those components. If I hit export to whatever, that's it. And so that can be really nice for organizing things. If you want to manage hierarchy for like E3D, you can control things that way. Generally, it's just going to go and export into different sections. But if you want to break things up, you can do it that way. For piping, it can be really powerful for like layer information, which is another big one, is using that layer information. We talked about it briefly at the beginning, but layer information is super useful for, defining lots of information. It does go into Revit as the Revit family names. It's used for E3D hierarchy management. It can be used to break up the model. But another cool one is I can do, for instance, if I wanted to organize things based on scope of work, I can grab those and do a shift select. I could set their family type to be, Revit conduit, or I can export them just those independently. And that gets to the last part is the pipe exports. And basically going through and just, we have smart points. So this is a point cloud export. This one actually is super cool. This will export a point cloud that's only points near the geometry you have selected. So if you think about breaking this up, you can export all your piping systems into, one export for like going to Revit for all your different systems types. And then you can grab the point cloud that relates to that, and you can actually generate new point clouds just for those points, those pipes. And you can do that for structure, ducting, everything. So it makes a recap point cloud, and it's just points near what you've modeled. And that's really great for detail work. So if like adding valves and flanges is something you would rather do inside of Revit, instead of bringing your entire point cloud in, you can export just points near your pipe models for the systems you want to work in, and only view that point cloud data inside of Revit, which could be, maybe a gig for a big job. If you've got lots of pipes, but instead of hundreds of gigs potentially for like a really big project, or you probably wouldn't do that, but a big point cloud. So that one's a great one. So we are basically at time here. So I'm going to leave it open for more questions. We can kind of talk about some other items here for other point cloud things. Let's see, we got a lot of questions, so I want to try and work through those. Awesome. Okay, let's see. So Trevor's been answering a lot of questions, which is great. Let's see. So we got questions on Revit families. So for Revit specifically, the way that we kind of do it inside of for EdgeWise is we're actually we're taking our own Revit family objects and we're kind of importing them in as we need them, and using it that way. Now with this is a good one to actually talk about is we have a new Revit plugin that we've been working on. It's coming out as part of our tools for Revit plugin. So this is the free Revit plugin that we have with EdgeWise, or like from that you can get on our website. We're including a new import function for EdgeWise in that free tool, and going away from having it like only inside of the EdgeWise installer. This one is it's nice because it breaks it away, so you can have people with the import function without having to install EdgeWise necessarily. But the other thing is this one is much more flexible for like only importing exactly what you need on the fly and not importing everything. And that's a thing with the old plugin. The current one in the software is it imports all the geometry all at once no matter what, which is not ideal for some scenarios. But we're basically importing in geometry like our Revit family objects and filling in the details. And the recommendation is to switch those out with your preferred method or your preferred families. But it isn't based on a template. It's actually dynamically pulling in the Revit family objects as they go. Let's see. So good questions here for steel. So if we are dealing with structure and there's deflection, really that's something we don't have a way of modeling the deflection as far as the like if there's a bend in the steel, you can see it, and there are some interesting things for like the heat, like for being able to export smart points and the point cloud information. The best way to kind of tell though is you can see it in the smart sheet. If a good example, and I can kind of simulate it a little bit. If this thing's bent and I'll just move this thing around, you'll see a spread of points like this. And so the spread of points just means, it's not a straight line. And so this one we see a lot. The way you can kind of tell if it's just more of just like not extracted correctly, like we have right now, where it's kind of sticking out at the top, is you can run refit, and it'll actually automatically kind of realign the steel with the point cloud and try and get a better fit, and it usually tightens up that point cloud. So if you do that and you still see a big spread of points, that's where you're going to know that there's some deflection happening. But the refit is really nice for being able to like really cleanly make sure that the dimension is fitted well. That's a great, yeah. So I think Trevor already answered that. So a question came in, there was a question about, clean and easy connect, messing with settings of things. That is something we fixed a long time ago, is that if you run easy connect, if you run clean, if you run apply standards, if you edited an object, we do not unedit it for you. So, if you go through and you do actually edit elbow bin radius, if you're going to Revit, if you're going to step file, that will go directly, and applying standards, applying clean will not affect that. We leave those alone after if you've messed with or modified anything inside the project. Let's see, we got a lot of questions. First, I think so. Web joints we have looked a little bit about adding some new steel elements. That's something that we haven't really addressed too much, but that is a good question and something we'll have to look at. Okay, so Plan 3D should work. It's just really specific to the built-in specs with EdgeWise. Basically, we have our own catalogs that we import into Plant 3D, and it's tied to it. It's possible to do custom specs with Plant 3D, but it takes a lot of manual modification, with modifying both the like the item numbers and things like that in the catalog to match what EdgeWise is doing. So it's possible. It is tricky, and it is something we're also looking at. Okay. So short T-joint is oh, that's a great one. Okay, that's a good one. T-joints, this is a sneaky one that I found a long time, a couple years ago, but sometimes there's spots where, so there's a couple things that are kind of tricky, especially with T's. One really frustrating one is just specifically about diameters. I think we're looking at addressing that one, is that if the main section of a pipe T is bigger than the secondary is bigger than the T, you can't connect it. generally we recommend it standardizing. I think we are trying to loosen that up a little bit so you can make connections, but we're experimenting with that at least. But a good example, where can I find a good spot? I can kind of simulate it over here. So something where like if I had, I wanted to make a T here, and how fast can I do this? Um, and I don't have enough room. One of the ways you can do that is you can basically go through and you can use you can change the elbow bend radius to give yourself more space. So that one's a pretty fun one that can be really helpful. We're just going to guess that it's the x-axis. Select and see. All right, close enough. So if I don't know why I did that. I could just do something like this. Well, no, I want that. So if I have something and I don't have room, so I'm just gonna, this is very sloppy, but we're just gonna kind of stick it in here. So if I do something like this, and I want to make this T, this will be tricky because the elbow is in the way, right? I don't have enough room. If I try and make a T here, even if I were to bump it over a little bit, and you can hold the scroll wheel and you can move, just shift stuff. So if I try and do a T right here, it's gonna say I don't have enough room, right? The way you can get around that is you can go to the edit function, you can edit the elbow bend radius, you can make it tiny. You can then add your T in, and then you can go back to your elbow radius and you can kind of put it back-ish. It's probably better to keep it, you don't want it to overlap too much, but that can be super nice. That's how you can get around. That's a good one to get around. Cannot convert. So I'm trying to keep up with questions. They keep coming in. I do. So there's not really a way. I love that question, but there's not a way to edit the elbow or the T length, unfortunately. And really, the right solution is to not have a T physically here, but do like an insert type connection. That's we'll have to look at that one, but there is no way, unfortunately, to edit the T size as far as I'm aware. It's kind of big, which is unfortunate in some scenarios, especially for like if it is not actually a T and it's a cut, like a hole that was cut out and welded in. Let's see. I have two different projects, each using different versions. Interesting question. So the question on autosave, that is hard coded. We are able to change the autosave directory. I mean, in that case, Revit contents. Interesting. So anything with the Revit plugin, I would really recommend anyone who's using Revit on a daily basis really check out the Clear Edge 3D tools for Revit. Free plugin. Mainly, it's got some very nice functions for actually controlling the point cloud, but it's also just has the new version of the import tool, which is way more flexible. It's should play nice with doing different it should play a lot nicer for international versions of Revit. It only brings in what it needs. It's faster. There's lots of advantages for it. It's pretty much just the same functionality, but just we try to do it more standard than what we did many years ago for the first iteration. So we don't have deformation analysis directly in EdgeWise. Not something that's like a global tool. That is something related. We have another product named Verity that would be something along those lines for connecting it. That we can kind of do some follow up there. There are ways to review the thing and then approve and kind of follow along. But that's something that we're also kind of thinking about is how to kind of continue to do QA throughout the workflow. How are those Okay, so let's see. CloudWorks, so CADWorks. Yes, we do work with CADWorks with the PCF export. So that was it's been around a long time for this one, but we do have PCF. It was made for CADWorks. And I believe there's a function you can import it in, and then there's a command to basically convert to native geometry. I don't remember what the command is off the top of my head, but we can help on the support side for giving more explicit instructions, but it's basically PCF out. Let's see. So standard sizes. So the standards for piping are located in the file tab, and then it's going to be the pipe standard editor, and you can see all the sizes there. Kind of span the table out for the different pressure ratings for those kind of primary values. Structure is a little bit different. So structure is we have an import standard. So you have basically you would export one of the existing standards, you can modify it, and then you can import it back in. When you import it, it is saving it to your documents folder in a standard like an EdgeWise standards folder. But that's going to dictate all the different sizing and other information. Okay, modeling above ceiling, stat areas. So above ceiling is tricky for sure. I mean, I think there's some different ways to approach it. I think it is, something I do suggest sometimes is like the manual tools can be really nice on their own. So like we obviously do push and suggest using the auto extract stuff a lot, but I think there is advantage. You could just make a new pipe model, and a new blank pipe model. And so some stuff that's really congested, it may be better to just run to model by hand in that case. If you are dealing with a congested above ceiling, I mean, an option is to run extraction and then you basically delete everything above and below, kind of the plenum space. That could be useful to help kind of clean things up, but that is a tricky one. There's a lot of dust up there, and who knows what else. And it is just it's a difficult job to work on. It's hard to even get a scanner up there. A tap instead of a queue parade. Yeah, I would love. I mean, that's a good one. And again, if you have feature requests, it's a great time to put them in. We do have a feature request item as well on our website under the support section. So any feature requests, we're very much keeping an eye on here. We're doing a lot of stuff right now, just like really trying to look at the workflows and try and improve things. But yeah, I would love for T's to be not actually a T and just doing an insert. That's a good one to talk about. So let's see, scanner types. So like a BLK, I have seen, it depends on what you want to do. So like a BLK, that's kind of in the lower side of, where we can really, we're getting on the edge. The BLK2 has been pretty good. We've actually been pretty impressed. I mean, for the price point, it makes perfect sense. It just depends on what you're trying to extract. If you're trying to extract 2-inch conduit or 1-inch conduit, that's not going to work, right? Like if you want to do walls, if you want to do large I-beams, if you're doing piping that's 6 or 8 inches, that actually can work pretty well. It's if it's not too far away. If you're trying to model, stuff in the ceiling that's 30 feet in the air, and then that's going to be a problem for a while. It's really susceptible to distance. So the BLK to go, we've seen the data for it. It does have trouble with auto extraction, so I don't think I can recommend that right now, at least with what I've seen recently. Or semi-recently, but the BLK2 has been solid for larger geometry. We'd still always recommend kind of the more standard workhorses. The better the data quality, the better your extraction and kind of your overall modeling experience is going to be. Let's see, tab and So let's see, Civil 3D. I'm not super familiar with Civil 3D export options. We do have a ground surface model that we can do that's built in, that's been there for a long time, and it only works with just structured point clouds with the terrestrial scans, but it can do like a land XML file. Outside of that, Step is probably the only thing that would really go to Civil 3D. Is it just kind of a stock geometry export? If you want to represent some basic stuff. I love the grid thing. Yeah, so structure, we don't have a way of locking stuff. At this time, there is ways to kind of individually lock elements, and so you can like click on, a piece of steel and you can say snap to vertical. But obviously that is going to that's not really sustainable across the entire project, so that it's a tough balance. There is an alignment function that can be very nice, and I'll kind of point that one out real quick. And I'm going to just kind of do a quick, how do I do this efficiently? So the alignment function is really just about trying to get like a bunch of horizontal stuff to all match up. So like a mezzanine or something like this, or even this. And so the basic idea here is like if there's misalignment with this section, so like say it's, not quite right, there is this align function. And so I can go through and I can say, go to this side and then actually go to the top of the I-beam, and that will level it off with that edge. And that could be really nice if I grab, a bunch of stuff. You can do that if it's all kind of on the line. That's kind of the best we can do for like what's in right now is basically kind of covering it that way. Okay. I think we're going to toss a poll in to kind of follow things up or to last minute with people that are in. And I appreciate all the questions. I mean, it's fun to do this. I know it's a lot of information, but we want to, hear everyone's thoughts and try and keep up with the questions. Let's see, polls. Okay. Awesome. Thanks everybody for continuing to answer that. We almost got everybody in. Wonderful stuff. Yeah, so we'll definitely, reach out for any information there. Let's see, keep answering questions here. Revit plugins that are supported. So we try and follow the Autodesk approach, which is we support, and we're a little more lenient than that, but it's the current 3 years and like one extra one. So like generally, like we'll support 2025 reasonably. 2025 was a tough year for Revit developers, but we got through it. But hopefully 2026 is a little easier. But we try and keep up reasonably with the new year, and then we basically say, okay, the next 3 years after that, we do have stuff. I mean that goes back pretty far, and it is an option we can talk about if you have some extenuating circumstances. But that's our general policy. Cable trays are tricky for the joints. I do not disagree there. Our systems defined once imported into Revit. Ooh, that's a great question. So we touched on it just for a second, but system types can be defined at least roughly inside of EdgeWise on the high level, which is if we go to the chain info smart sheet. So this is the spreadsheet for looking at like the entire run. There's a Revit family, which is not the right naming for it. It's really should be like Revit system family type. But this is basically when by default we're going to make pipes. When you import into Revit, it's going to be a Revit, a pipe system. You can define it as conduit or ducting. And so if you set stuff to ducting or conduit, when we go to Revit, it will be a conduit, Revit system. And you can switch it out with any other conduit element. Same thing for ducting. But you got to do that inside of EdgeWise before you export. There are custom tools out there that can do the conversion if you missed one, but the nice thing is that export on selection. So if you do miss that, that's actually a really nice improvement in the workflow. Is like you used to have to export the whole, like basically start over, right? You delete everything in Revit. You have to set the status is correct and then re-export from EdgeWise. Because we have a selection, export on selection, that was one of the things that really helps with that is you can, if you miss something, if you forget to model something, if you forgot to set the Revit family type, instead of having to start over, you can just export that new thing that you did, and that will go into Revit, all on its own. So that's a big improvement into the workflow, and I think that was released like 1 or 2 releases ago, like 4 months ago or something like that. I forget which version, but that's a big one, and that's super nice for being able to like not have to start over after you export your final, after you export it out of Revit. It's just export with anything new or modified. You should delete that on the Revit side, but or the Plan 3D side, whatever. But that's a big one. Let's see. I think there will be a webinar for modeling walls and stuff like that, and other pieces that we missed. I think it's just based on interest. So we don't. There's not really a way. The best we can do for the question is, can we identify the difference between pipes and conduit and ducting? The software can't do that automatically today. So that is something that you would, as the user, you need to. Generally, it would be a shift select, where you can control click in the 3D view. That's another nice item. So we can do control click, and grab a bunch of stuff, and then you can do multi-edit to, change the Revit family system type. Ironically, these are definitely pipes, but that's kind of, that's something we are thinking about. But it is, something you need to look at, basically to find yourself. Let's see. It can't, so topography we can do. So the scan data, I mean, it's super flexible with the scan data. It is generally, as long as it's like, there's a margin for scan data types that we can work with, but we should be able to cover a lot of different examples. Interior open plan map in the next one. Sure. Yeah, I think we'll be doing more of these. Uh, awesome. Okay. Well, I think looks like questions are wrapping up. We're over our kind of time set. Uh, we were kind of curious to see what the interest was. We had a lot of people jump in, a ton of great questions. So I think we'll probably do more of these. And if people are interested, for sure, we'll look at it. Any other questions? If you want to toss them in, we'll kind of wrap up for today. But we'll follow up with anybody who tossed questions in. And are interested in training themselves. And we will let you know if for doing another training, kind of going into different parts of the software. Yeah, and then recording will be sent out, and so we'll follow up with everybody. It'll take a couple days, but we'll send out the recording and send it over. And yeah, thanks everybody for jumping in. It was fun to kind of show some tips and tricks from we've learned over the years. All right, thanks everybody, and have a great rest of your day.